All right, hello guys. My name's Aaron Leacock. Thanks for sitting in on this webinar about the distributed custom members and plugins. This webinar I'm going to be talking about the custom members and plugins that are going to be distributed with 7.3.1.6 and higher. These were all these custom members and plugins that I'll be showing today were developed and will be maintained by Bruce Vaughan, who is a member of our advisory board and the current user group president and a longtime SDS2 customer. He can be contacted at bvdet@comcast.net, or you can also find his contact information on our support page on the website under the advisory board information. Want to get started here, I want to make a note. It's important to know that these plugins, if you've had previous versions of these from Bruce, SDS2, if you have multiple copies of this in the data directories plugin folder, you have no idea which one SDS2 is actually using when it pulls up the custom member. So what we want to do is, if you have older versions of the plugins you got from Bruce that you want to keep using on older versions of older versions of jobs or anything like that, you'll want to copy those out of the data directories plugin folder and copy them into the jobs plugin folder. SDS2 will always default to the jobs plugin folder and use plugins out of there over plugins in the jobs data directory. So to show you guys where this is at, I'm going to go open up my 7.3b directory and my plugins folder. You'll have a distributed folder in here and a folder called BV. Inside here will be the custom members and plugins that we are distributing in 3.1.6 and above. So these are what we're going to go over today. So let's go ahead and get started here. Jump into modeling. Select my view here. To start a custom member, you can do it a couple ways. You can go to the model pull down under member, add, and prompt for member type, or the F2 key. You see the keyboard shortcut there. And here you will see your custom members. They'll have the BV next to them here. These are the ones that are distributed, the Bruce Vaughan's custom members. The first one we're going to show today is going to be just the concrete footing and column. So if I select that, it tells me to locate my concrete element work point. So if I come up here and use intersection of construction lines and pick the intersection of my grid lines there, you'll notice that I have, and just a pretty simple edit window here, I have concrete element type. I have the option for a footing, or a rectangular column, or a round column. So if I want, we're going to start off with just the footing. If I select footing, I can select the sequence, the concrete material color. This is just a red, blue, green color code that you can type in there if you know what you want. Any rotation you want to add to that footing. The top of footing elevation, in this case 99.2 is the bottom of my base plate. Then you have the length and the width and the thickness. So if I'll make this 3 foot by 3 foot, let's make it 2 feet thick. You can also offset this footing in the X and the Y direction if you need to offset it one way or the other off the point you selected. Because these are custom members, you do have all of the member status and custom properties option. This is a concrete element, so by default it is an existing member. It is set to yes. And you'll notice the member description is filled out to concrete element by default. So if I say OK to this, it'll put my concrete footing in here. It'll ask you if you want to add any more. So I can see that I have just a nice simple little concrete footing there based on the point I picked. Pretty straightforward. If I wanted to add the same thing, I'm going to use F2 for the prompt for member type. And I'm going to say concrete footing and column. I'll pick another point here. And I'm going to start off, I'm going to make this one rectangular, column rectangular. So you get your top of column elevation. I'll put this at the top of the building. Bottom of column. Make it the same thing as my columns there. And then you have a depth and a width. So how big do you, how much length and width do you want on the column. Let's make it an 8 by 8, and I'll say OK. So I have my concrete column in here. If I needed to represent some concrete columns or anything like that in my model, I can also, because they're custom members and not just parametrics, I can just double click on these and edit the information. So if I want to make this 4 foot by 3 foot, just come in here and say OK, and it'll update the information for me. If I wanted to edit the column here, because I selected column, I can change it to round if I wanted to. Let's say I want to make this a foot diameter. It'll change those for me. Okay, so that's a pretty straightforward column footing and column concrete column. The next one we're going to look at here is the crane rail. So I start F2, and I have my crane rail custom member here. That's going to ask you to select 2 points, point 1 and point 2. So I'm going to pick 2 points here, and you're going to have pretty simple information here. You have the left end, the point 1 elevation, the point 2 elevation, setback information if you want any setbacks, rotation of the crane rail size, and one of the nice things about this custom member is you can change the member line location, either the top of the material or the bottom of the material. Again, you have your material finish, the color of the material, whatever color you want it to be, and sequence, depending on what setup in the model will show in this drop down. Again, you have your member status and properties just like any other member. So I can say OK. It's going to put in my crane rail. Pretty simple right now. The member lines at the top, you can see kind of the target there at the top of the material. If I change this to the bottom, you'll see the material shift up and the member lines at the bottom of that material. You can also add rotations. If I wanted to rotate this 90, it'll rotate at 90. Okay, that's a pretty straightforward one, not too complicated. The big benefit to that one is being able to swap where the member line is in relationship to the material. The next custom member here is going to be the tilt-up panel. So we'll start our tilt-up. And again, you're going to have to pick 2 points, point 1 and point 2. And then it's going to ask you to fill out the panel thickness, the top of panel elevation. Let's put this to match our building here. Bottom of panel elevation. Point 1 and point 2 setbacks. If you want to bring any setbacks from these 2 points you picked. You can specify the sequence, the material, the concrete color. You also have end chamfer information if you want to add these chamfers to the either end of the tilt up. You have no chamfer, member side or other side. So member side, the chamfer will be near the member. The other side will be away from the member. So I'll just set these either one and say OK. And you'll see that it adds this chamfer in there. If I wanted to change this, I can just come back in here, swap them, and it'll flip it around for me. The last tab here is called Panel Slope. If I look at the image here at the end, you can see that I can add a slope to the top of this tilt-up if I need to add a slope to it. So I can come in here and I can do an angle left and an angle right. Now the angle left has to be a positive angle, so I typed 5 degrees in here. An angle right has to be a negative degree, so I type -5 in here. The last field here is distance from right end to peak. So if I typed in here, let's do 5 feet and say OK. And look at this. You'll see that it put the peak halfway between because it's a 10-foot wide panel. If I wanted to change that, I could say I only want slope on the left side. So we'll make this side, the right side flat, and just slope the left side. This is another concrete element, so by default it is set to existing, and the member description is filled out again to tilt-up panel. Okay, pretty straightforward. Once you input these members You will have model complete date fields in here, so even this crane rail as well, of a model complete date set, so you can set those model complete if you need to. All right, moving right along. The next one here is going to be the rod brace. So I come in here, I'm just going to create some construction lines. And let's go down 3 feet. So this rod brace custom member is going to ask you to select 2 points. So I'm just going to pick 2 points here. In here you have a couple tabs. In the general tab you can specify the 0.1 elevation, 0.2 elevation, setbacks, and thread lengths for those points. You can specify an x-axis rotation if you want to rotate the rod brace. You can control the rod diameter, the rod grade, finish, color. In these fields here, if you right-click, if you don't know the color you want, some of his custom members do not have this option, but a lot of them do. You can go to a color dialog, and you can change this color to whatever color you want, and it'll save that red, green, blue value in there. You can also select a named color if you have a saved name color in SDS2. Again, you can set your member sequence. In the Clevis and Turnbuckle tab, you can specify whether you want to include clevises on each point, the clevis size, the clevis grip, pin diameter, clevis rotation. You can add a clevis pin, yes or no. The pin material, finish, color. Again, this gives you a preview over here to the right. The color that's showing up here is actually the preview of what that material color is going to be. And then turnbuckle information, the number of turnbuckles, turnbuckle size, rod setback at turnbuckle, rod thread length at turnbuckle, finish, color. So the number of turnbuckles is also related to the first rod length. So depending on your first rod length, those are going to be the distance between the turnbuckles. So if I specified this just to be 10 feet, and I just have one turnbuckle, I'm just going to say OK to this. And there's a tab here for images that gives you some dimensioning images here to kind of give you a better idea of what the values are. So the first thing you'll notice for people who are used to the rod brace parametric is this does not design connections. This is just a point-to-point at where the clevis and the pin location is. Okay, so 10 feet from the point 1 is the first turnbuckle, and then since I only have one turnbuckle, the rest is just a regular length of rod. If I edit this and I say I want, let's say 2, and I change my rod length to, let's say, 7'6", it'll put 2 turnbuckles in here if you need that. Okay, so you can also edit this member and add a rotation. If I want to rotate it 90, it rotates the entire member 90. So the clevis is a rotate if you want to do this in like a horizontal plane, if you want to run it between 2 members horizontally or anything like that. All right, so these first few have been pretty straightforward, pretty simple to kind of get in here and not worry about. The next 3 here are going to be a little more advanced. So we're going to get to another view here. Let's just go 114.6, and we're going to do the embed angle custom member. So I'm going to select that, and I'm going to have to pick 2 points. So I'm going to pick point 1, point 2. Now in here, there's quite a few tabs. We're going to kind of go through this and try to get them all gone through so you can see everything. The general tab, again, elevations for point 1 and point 2, any web or flange cut angles. So if you want to cut any of the legs on an angle, you can. Setback information, rotation of the member, material Y offset, so you can offset it from the member line. If you need to offset it up a couple inches from the member line you selected, you can, or down. The galvanizing options, do you want to galvanize or duplex coated? Right now in these custom members, the duplex coated will cause you some problems. the tag got changed from duplex coated to duplex coating in SDS2, so this currently duplex coated does not work in these custom members, but that should be fixed relatively soon in one of the next releases, I would think. You can also control the angle size, the long leg direction, grade, finish, prefix, and then in here you can actually control the member description. What do you want the description for the member to actually be filled out as? In the studs, you can control the stud diameter, length, grade, finish, stud material color. Again, you can right-click in here and get the dialog or named colors. And then there's a stud location information. There's placement, where there's an inside 45, outside 45, vertical, horizontal, both legs, and then vertical, horizontal, both outside. I think those are probably pretty self-explanatory. We'll go through a few of those. There's some images on the last couple tabs here. We're going to leave it inside 45 by default. Let's do a stud spacing of, let's say, just 2'6". Minimum dimension from point 1, 3, minimum dimension from point 2, so you can specify what your minimum dimensions are. The stud gauge on the vertical leg, if you're using a vertical or horizontal or both option. And then offset if you're using both legs option. We'll look at that when we look at the both legs. You do have holes, or you can specify holes in this embed angle as well. You have a couple different spacing options for holes. The spacing options are ends, which will specify the hole spacing and the edge distance and the number of holes from the end of the angle. We'll look at that. Spacing, which is just going to be minimum dimensions from point 1 and then exact spacing between it. And fixed dims, which means it's going to be a fixed dimension from the ends and a maximum spacing between it. So we'll just look at ends first, and I'm just going to do hole spacing. Let's just do 1 foot. Edge distance, let's do 6 inches, and I'm only going to do 1 holes for now just so we can look at this. Now there is a checkbox up here to add holes. If I have this checked, or to add bolts, if I have this checked, I can go to the bolts tab and I can specify what size bolt I have and that sort of stuff. We'll look at this here in a second. There's a plan tab to give you some dimensions and an elevation end tab to show you some of the different rotations and stud location options. So I'm just going to say OK to this and get this in here just so we can see it. I come down here and look. I have studs at the 45 inside, and I have bolts and holes. This is 6 inches from each end. I only have 1 on each end. If I come back in here and look at my hole patterns, and let's say I want 2, it's going to give my 6 inch and then my 1 foot spacing like I have in my set up in my hole spacing. Okay, so I can also do a spacing, or let's say I want a spacing of 2'3", and the minimum dimension from each end is 6. And 2 inches should be fine. So the 2'3" spacing is exact between here with a minimum dimension on either end. And the opposite there is going to be the fixed spacing, fixed dim, where the dimension from the ends are exact and the maximum spacing between it is a maximum 2'3". So in this case, this dimension will always be 6, this dimension will always be 6, and these will be no more than 2'3" apart. You can turn off bolts, like I said. So I come up here and I can turn off the add bolts, and it will not put the bolts in the holes. If I have bolts added, and I go over to the bolts tab, I can specify, like I said, the bolt size, the type, the class, field, shop, or auto, the bolt finish, and I can control which way the bolt is going, whether it's in to out or out to in from the nut to the head, the size of the amount of the grip side, inside or outside, the bolt length, tension control, and nut and washer information down here. So let's look at some of these options up here. I turn the bolts back on, and the grip. We'll turn these bolts back on just so we can see it, what it looks like with just the default. If I say I want to set the grip side to outside, my grip is 6 inches, it's going to put the 6 inches on the outside of the angle. If I now set it to, let's say, out to in, it's going to flip the direction but still leave the grip on the outside of the angle. I can set it to inside now, and it'll put the 6-inch grip on the inside of the angle, but the bolt direction is still the same. You can change the length, add any of the bolts you want. If you don't want tension control, you can turn that off. Okay, going back to the studs, let's look at some of these more of these options on the studs. Obviously, inside 45, outside 45 is going to be on the heel of it. I have vertical and horizontal legs and both legs. So if it's set to both legs, I have a stud both leg offset. So if I don't set that right now, let's just make sure. If I don't set that right now, they're going to cross over each other because they're exactly the same location. If I want to basically set an offset, I can just come in here and let's say 2-inch offset. They're offset 2 inches. Same thing if I selected the outside both. Okay, so you can keep editing these. Again, you do have a graphical galvanized checkbox up here, model complete date if you want to set that. There is a swap endpoints, and what this does is really just rotate it 180. So if I say yes, swap endpoints, it just basically flips the angle. Your 0.1 becomes 0.2 and 0.2 becomes 0.1. I can just keep swapping them and it'll keep flipping it around. Okay, so that's the embed angle. That one's not too bad. The next one we're going to look at here is the embed plate. So if I start F2 and look at embed plate, it's going to come up with giving me a couple options here of how I want to input this embed plate. So I have select member bearing plate, select embed plate endpoints, and select reference point. I also have an edit setup data and an exit, which will just close the command. The edit setup data will allow me to go in and set my defaults and edit those without actually putting in a embed plate. We're going to start with select member. Say OK. It's going to ask you to select a member or joist member to add this embed plate to. I'll just select this, and it's just using the member to locate the plate. It's not actually adding it to it. So in here, there's quite a few tabs. We'll go through these. It's going to take us a while to get through all this stuff. In the General tab, you can specify which end of the member you want to set it to, the left end or the right end. This is going to be the left end of this member. The member plan rotation. So what rotation do you want this embed plate set to? 0 will be the plate will be horizontal, not at basically what would be at the end of the member. So if I say -90, it'll rotate that embed plate the correct direction for the end of that member. Distance from top of beam to top of plate, so that's going to be from the top of steel to the top of the plate, so 3 inches above it. Member x-axis rotation, that'll rotate it along the x-axis. You can specify the grade, finish, color, the length, depth, and thickness down here for the plate dimensions. You can specify this ahead of time, or based on what you put in here for the studs or DBAs and the spacings, it'll adjust the length to make sure that it's not too small for the stud that you're putting in there, for the spacing of the studs or DBAs you're putting in there. In the Common tab, you have the stud material finish and DBA material finish, the galvanizing finish type, the stud and DBA material color, and any offset, vertical and horizontal, of this stud or DBA patterns. On the studs tab is where you can specify the number of studs, rows, spacings, and vertical spacings. Same thing with the DBAs and holes. You can specify what type of DBA, the length, the diameter, the rows and spacings. Same thing with the holes. You can specify the number of hole rows, columns, spacings, the bolt attributes for those holes. So let's go back to the general tab here. Make sure this is set. We're just going to do a simple studs here of number of rows. Let's just do 3 columns, 3 rows. 8-inch spacing and 6-inch spacing is fine with me. You'll notice down here at the bottom it says minimum plate dimensions for studs, DBAs, and hole patterns to fit is 1 foot 6 by 8. When I started this one, it was 1 foot by 1 foot plate. If I go back to the general tab now, it is now a 1 foot 6 by 1/2 plate. So we'll increase that plate size for you to make sure that it will fit the pattern that you have on there. If I say OK to this, I can look at this embed plate, nice simple embed plate. If I edit it again here, and let's say I wanted to add some DBAs, if I say I wanted 2 and 2 and say OK, it's going to add the DBAs right to the same plate. If I wanted holes in here now, I could say I want, let's say 1 column, let's just say 2 columns, 2 rows, 5.5, 5.5, not quite matching up with anything else yet. We'll say OK, and it's going to put those in there as well. Okay, this is because I have it set to the studs, DBAs, and holes plate anchor type up here. It'll allow you to put all of these in here on top of each other like this. If they were set up the exact same, if my DBAs were 3 and 3, it's just going to basically run right over them. It just puts the material right on top of each other. So if I can make sure they're not lined up like that. The other options for the anchor plate type, you have a mixed anchor option. So when it's set to mixed anchors, there's a tab here called mixed. In this tab, you can specify the number of anchor rows and anchor columns. So if I say I want 4 by 4, I get a 4 by 4 table down here. And if I read this little note up here, it says enter S, D, C, H, or a dash into the table for a stud, DBA, coupler DBA, hole, or no anchor. So I can come in here and I can fill out what do I want in each of these 4 by 4 column and rows. So if I say I'm going to put some studs across the top, let's do DBAs across the middle, and we'll do the coupler DBAs there, and let's just do holes on the bottom. If I say OK to that, it's going to do the fill out that pattern with what I want on there. Now, so the couplers here, you can, if you ever have a call for a coupler, you can use like mechanically attached DBAs that don't need to be welded. If I don't want something in the middle here, I could come in here and just put a dash, and it won't put anything in the middle of that plate. Okay. You can also control on here the spacing. Notice there's a comma here. If I wanted to do 8, since there's 4 columns, means there's 3 spaces, 8, 2, 8. And let's do the same thing here, 6, 2, 6, and say OK. It'll basically create that spacing between those in the columns and rows. So you can specify different spacings like that. Then you can also offset it back here on the common tab if I wanted to offset it one direction or the other. So the DBA type, again, they're straight square hook. So if I wanted to look at the square hook here, it just puts a square hook there. If I wanted to set it to the J-hook. Gives you just a nice rounded DBA there. You do have options in here in your DBAs for the rotation. So if I wanted it at 0, I could put it at 0. And then there's also an option in this DBA tab to rotate alternate DBA rows 180 degrees. So if I say yes, and there's an alternate row of DBAs in here, it'll rotate them 180 degrees from each other. So if I came in here and I say I want this one, I'll say 180. I'll flip them the other direction. If I wanted it at 270, crosses them like that because of how close they are. Okay, so that's the mixed anchors plate type where you can specify a pattern like that. The last couple ones here, anchor holes is just going to be holes. The plane is just going to be a plain plate, not going to have any sort of studs or DBAs or anything on it. The last three on here are stud space, DBA space, and hole space. What you can do with this is you can basically put in like a 10-foot long embed plate with one of the next options here with selecting the end points of the plate. And you can tell it what type of stud spacing you want here, whether a fixed, which means the fixed column and row spacing, and a minimum edge distances, or a calculated, which is a maximum row spacing and fixed edge distances. And you can, on like a 10-foot long plate, you could get 10-foot equally spaced ones if they're going to cut them up in the field and use them, or something like that. If you need to ship a big plate and have it cut in the field, you can do that. So let's look at some of the other ways of putting the plates in here. The last thing I want to talk about before we get onto that is the job standard plate. There's a drop down here that has some looks like plates saved on it. If you look to the right here, there is a yellow button that says Save Standard Plate. So if I wanted to save this plate as a standard plate that I just created right now and save it, I'm going to hit the Save button, and it's going to say enter the plate name. So I'm just going to call this Webinar. Say OK. You'll get a message saying the XML was written to disk and reinitialized. This custom member uses an XML file to initialize some of the information that it needs. So that's all saved. If I want to add a new one in here, let's look at one of the other input types. So embed plate. Let's say select member, but I want a bearing plate. So I'm going to say select member bearing plate. If I select this member, you'll notice that the member plan rotation is -90, but the member X rotation is at the 90 degrees for me automatically because it's going to be on the bottom of this member. So if I wanted to load that one I just created, I can come up here and say my webinar that I saved to that standard plate of. It'll fill everything out for me automatically and say OK, and it puts that plate on the bottom of the beam on that end. Okay. The one thing to note about the embed plate here is when you put this in, you do have options from the distance from the top of the beam and the distance from the end of the beam to the work point of the member line. Okay, so if I want this set back 6 inches, let's just put a simple bearing plate one in here, say OK. So put it back 6 inches, it's a simple bearing plate on the bottom there. One thing to note about the saved standard plates is that the nailer hole information is not saved with them currently. So if you have a special, if you need 4 every time, you'll have to change that on the nailer hole information for these. Okay, so again, you have the galvanized options, the model complete date options. If I keep going down here, here's the nailer hole information if I wanted to change it. 0, 2, or 4, edge distance, nailer hole size. You have some images here to kind of give you some different options here. And then at the very end, there's a setup. The setup will allow you to determine the variable options, whether you want that coming from the XML data or just the last values used. You can change that. And then if you've noticed, there are little X's underneath all the studs and DBAs. These are the CNC marks. You can turn these off if you don't want those on there. Minimum anchor edge distances. So the minimum edge distances, this basically helps determine the minimum size of the plate based on the spacing. So if you want a minimum edge distance, you can change that here as well. Okay. So let's look at just adding it with a couple points here. So if I hit F2, select my embed plate, and let's say I just want to select my embed plate endpoints. So it's going to ask me to select 2 points. So if I select just 2 points here, I have a member x-axis rotation. The plate length is the length of the 2 points I picked. Again, all the same information. I can put in a different, let's do a Michelin W12 in here. Say OK. So right now, remember the values of the last plate I put in here, which is a bearing plate. So this is rotated 90 degrees in the x-axis. So it's going to be the same thing as the bearing plate over here. I can just edit this and set this member x rotation to 0. Flips it that way for me. If I want to flip the other direction, I can either change this to -90, or I can use the swap endpoints option like we saw on the embed angle, and that'll flip it around for me. So just picking 2 points. Those 2 points you pick will be the top of the plate. Okay. The last way to input this plate here should be with just using a single point. So let me just put a construction line in here again. And if I say embed plate, and now remember is the last input selection, so it's wanting me to pick 2 points. So if I don't want to use that input selection, I can either hit escape or right click. So if I hit escape, it's going to say, okay, well, what type of input selection do you want? So I'm going to just say a reference point. This reference point is going to be just a single point. It's going to be the middle top of that plate. So if I select right behind it here, it's going to use that point as the top center of the plate at the back of the plate, which would be the side the beam will be framing to. So I can fill out all the information here. Let's pick another one here. Let's pick a Michelin W21. And so just by picking just this single point here, it puts it in here and references it based on that. The point's going to be basically right here, center of the plate at the back. All right. So that's kind of a good overview of the embed plate. If you have any questions on that, just give us a holler at support. We can help you through a lot of this stuff. The last custom member we're going to talk about today is the Sag Rod Custom Member. This has quite a few uses and quite a few advantages to being used. So I'm going to swap around to the view here. Okay, so I just have some some girts put in here on the edge of the building. Got some construction lines set up here. So I'm going to start my Sag Rod Custom Member. Okay, so it's asking me to select my point 1 and my point 2. So I'm going to come down here and pick, if you notice right here on the, what I would call the inside of the channel for that point, and the top of the channel for this point. You'll see why. And I'll have an option to select either a straight, a bent, straight plus hook, or a bolt style sag rod. We're just going to do a straight one first. Okay, so in here again, there's quite a few tabs in here to kind of get this set up the way you want it set up. You can specify the rod diameter, the x-axis rotation, the rod type. If you want to change it once you've inputted it, you can select straight, bent, straight hook, or bolt. Material color, member sequence, round off length. Do you want to round the lengths off at all? Round off nearest 2. The elevations, and here you have a 0.1 setback, so it's going 2 inches past the points we picked. 0.1 thread length, 0.2 thread length. Connection type. So what type of connection do we want here to these girts? So we're going to always just set it to web flange holes. The other options in here are from older versions of the Sag Rod Custom Member, and they were added differently except for the floor clip down here, but the web hole, bottom flange hole, and top flange hole were added to kind of speed things up, but we added some modules in SDS2 that have been incorporated in this custom member that work great with just adding it to any of the locations, webs, or flanges. You can specify the nut quantity, double nuts, yes or no, washer quantities, bearing plate washer, rod end to bearing. So from the end of the rod, where is this going to be bearing at? So since we have it 2 inches past the point we picked, we want the rod bearing to be 2 inches back from the point we picked. And this will make more sense. I'll give a demo of this in a little bit. The grip, and if you had a bent or a hook, you can specify the hook dimensions and the bed lengths. Galvanizing options, again, if you want to specify duplex coated, again, this doesn't work currently because of the tag got changed from coated to coating. The finish, you can assign a finish to all material in this custom member. So all of the plate washers, the rods, everything, you can assign a single finish to all of it. You can specify the nut and washer and the plate washer information. So here's your nut 1, nut 2, grade and type, nut finishes, washer data for 0.1 and 2. You have your plate grade and finish and color, and your 0.2 and 0.1 plate thickness, plate length, and width. So let's just take a look at this here just to get a simple, straight sag rod in here. Now, the difference between the sag rod and the other custom members is it does require processing because it will add holes to these girts. So if I process this, I will see that I have my sag rod in here, bearing to the locations I selected. The holes are added to the girt. You can see as I hover over that, the outline of the hole shows up. Okay, so I can specify the plate sizes, everything. If I edit this sag rod one more time and go to the nut and washer plate, if I wanted this to be, let's just say 6 by 6 for some reason, and reprocess it here, it'll give me a 6 by 6 plate here at the top. You can also control here on the support data tab the hole datas for the 0.1 and 0.2 in the girts themselves. So if I wanted an actual, say, long slot, let's just say a 2-inch long slot here in the girts, and I reprocess this guy, you'll see that now I have a long slot in that girt instead of a standard round. Okay, so that's a pretty simple straight sag rod here. Now they're just members. So again, if you've ever used the Sag Rod parametric, you always got spacing information to space it between the two girts. This is just the member that we would just have to go to our copy members, and if we just did a single copy, or you could do a linear, find our intersections here, and we could just select the points here, accept it, here, accept it, here, accept it, and I can process these again. So now I have sag rods across there with long slots on the top and the bottom. I can get that just by copying them over and reprocessing everything they process and get all the bolts and holes and everything in there correctly for me. The other type of sag rod we can do is a bent sag rod. So if I wanted to, I'm going to set some construction lines up here. Let's just say 1 foot's good, plus or minus, and I'm going to offset, let's just go 4 inches, add minus, and I'll just process these girts real quick just to make sure they're solid again. And I'm going to come in here and I'm going to add another sag rod. I'm going to select my intersection of construction lines there to there. And I'm going to select a bent type. When I do that, it's going to ask me to locate the bend location, the bend point. I'll pick there for my first point, and I'm going to pick here for my second point. Again, same information for the connection types, rod sizes, all that sort of stuff. I'm going to say OK and process this. And so now I have a bent sag rod based on the points I picked. So if you need to put a little bend in there, you can specify where that bend location is. Okay. This sag rod also does not have to go between girt to girt. It'll also work with beams. So if I come in here, let's just delete this guy. And reprocess this really quick here. And let's just cut a section through here real quick. So we got a beam here and a girt here. Let me just set this just to a foot so I don't see any extra information that's going to confuse me here. And if I add the sag rod again, I'm going to start right intersection construction line, intersection of construction line, select a bent. I'll select a bend location there and a bend location there. Now I'm going to come in here and I'm going to change my, let's just say 2 for the length on this. Process this guy. And if I look, it's just a bent between the beam, and it actually adds a long slot into the flange of that beam, long slot into the girt. So if you needed to connect it between different members, you can do that. Another kind of just to kind of show you the possibilities with this Sag Rod tool. If I come in here and cut another section down here. And let's set this back to a foot again. I'm going to select this Sag Rod tool, or excuse me, just a Sag Rod Custom Member. Pick my first point here and my second point right here. Select a bent and select my points down here for my bend points and process that. Okay. So I just add just a little bent sag rod between each flange. Maybe give you some ideas for the possibilities you could use it for. If you wanted to, you can go between, columns, beams, girts, and that sort of stuff. Okay. The last few styles of girts here, or of sag rods, you can input just so you guys can see them all. If I pick the right points here. Is if I say a straight hook, I can specify the hook dimension, the point setback, so how far it's going to extend past the points I picked, the web connections. If I just say OK and process this so you can see it. It's a nice little hooked sag rod. If I wanted to rotate this, I can come in here to my x-axis rotation, and let's just say I wanted a 90. I'll rotate that around. I could extend that dimension with the hook length, hook dimension. Send that to 6 inches. Again, remember, I can edit this and change the type right here in the edit window. If I don't want a hook anymore and I want a bolt, I can say OK and reprocess. And at the bottom, it'll give me an actual, basically a material bolt for that length. It'll fuse the bolt head onto that rod. So I can get a bolt style sag rod if I needed to. And the last thing I want to cover here for the sag rod before we get into some of the other plugins is the floor clip. So if this is just a straight sag rod, I can specify a floor clip, and in my floor clip tab, I can specify angle size, the angle length, the long leg direction if there were unequal leg lengths, grade, and then the bolt size, for this whole information, all that sort of stuff in the clip. You also have a clip distance down here, which is how far from the end of the rod to the bottom of the clip you can specify. So I'll just say OK to this and process it. And now I have a clip at the bottom here. If this was going to be bolted to the floor or bolted to anything else, you could do that. So that's basically the Sag Rod tool. Kind of give you some ideas of how that works. Hopefully got you maybe some ideas of how you could use it. The next things we're going to show here are going to be the plugins that are distributed. Now, the plugins are only accessible from toolbar icons. So to add these to your toolbars, you'll have to come up to your options pull down and go to toolbar configuration. And in your toolbar configuration for your command group, you'll need to navigate down to model parametric BVD. These are the last 3 distributed plugins that we haven't talked about yet. So I'm going to throw these on my toolbar real quick here. Just throw them on the little floating window there. Save that guy. Now, let's open up a new view here just so I can show you guys this. So if I look at this column base plate here, this first one here is just going to be a plate washers at base plate holes. So if you ever need to ship just plate washers for the base plate holes loose, you can select this. Now you can select based on the member or the materials, the members, the holes, or the members based on which base plate piece mark. So it'll prompt you for each different piece mark on the same member types for if you want different plates for different base plates on the same members that you selected. If I just say materials and select just that plate, and I can say right click and say OK, it's going to come up with just a pretty simple window here on what the length and width do I want for these plate washers. So I'll just say 4x4 by half. If I want to rotate, I can, sequence, grade, and whether they're galvanized or not. I can say OK to this. It's going to come in here and put these little washers on here. And basically all these are the Embed Plate Custom Member with just the anchor holes plate type. But if the tool comes in here, puts these all in all the holes for you automatically, you don't try to put them in here yourself. And these are all separate members that would be shipped loose. The next tool here is the Sag Rod tool, which is similar to our anchor rod tool, if you're familiar with that in 7.3. If I select the anchor rod tool, or the Sag Rod tool, excuse me, and say materials, I can fill out my sag rod information. Whatever type of sag rod I want, straight, bolt, straight hook, any plate washer information if I want to. Say OK. Come in here and it'll put all those sag rods into the anchor bolt holes for the material that I selected. So it's similar to the anchor rod tool. This is the Sag Rod tool, and adds Bruce Vaughan's Sag Rod Custom Member. The last plugin here is going to be the shape information. Now this is just kind of a helper tool, really. If I click on it, it just comes up with a window here, and it gives you basic shape information for the size that you selected here, for just the size in here. It's not what's selected in the model. It's just in here. You can browse I can select if I'm working with a size I don't normally work with, like a W36 by 256. It gives you basic material information on that size. You can also ask for infractions. So if I hit OK to this, I can actually get an output if I wanted to save it. If I wanted to print this off or save it, I could do that. Or I could hit cancel to it and it won't output anything. So those are the plugins that are distributed with 316 with Bruce Vaughan's custom members. There's one last thing that I want to go over here, which is coming down the road here in 317. There's a get the point plugin. If you've noticed, there's a checkbox in some of these custom members that I haven't gone over. This checkbox is enable GTP. Now what this does is it enables, there's a get the point, which allows you to get the specific location at the midpoint top of some specific members. These work with our anchor rods, base plates on columns, with the user base cap plates from the plate definition schedule, Bruce Vaughan's embed plate, embed angle, and sag rod, if you're using them as the anchor rods. So with his custom members, you'll need to enable the GTP to get that information out of there. So if that's enabled, what it does is it'll output a specific point when we run a specific tool, and I'll show you where that's at here real quick. So if I go back to my tools, this is another plugin that will be distributed in 317, and I find just my regular model parametric. There's this one here, get the point, a little target-like looking icon. And let's open back up a plan view here real quick. So if I run this get the point information, it's going to ask me just to specify a control points. These have already saved in this job because it looks like I've already ran it once. And if you can just pick 2 points. Now you'll want to select metric because this would go into Revit and Navisworks for point verification or stuff like that. So what happens is we'll get this file here. I'm going to say OK. I'm going to browse, make sure I save it to just my desktop here, and say OK. And it's going to come through and export points for 20 members. So basically all my base plates, maybe that one Sag Rod I just changed, or an embed plate that would have been in there. And what that does is it exports a Excel file. If we open it up here real quick, just a simple Excel file with point location for the members that have those points that we can export. So what that does, what people can use this for, is they import it into Revit or Navisworks, and they can compare that to maybe a field measured point in like Navisworks or Revit from a get the point software. So what it looks like, if I open up this little screenshot here, this is a screenshot from Navisworks. So it imports with a get the point manager. It's a plugin in Navisworks and Revit, and what it does, it imports these little red points here into a model. Now this is another IFC model that was exported out of an SDS2 job as well. And so you can look at these points and where they're located in the model, and if someone has a field scanned an actual location, you could compare these 2 points to see how far off they are. So you can do that. If they need to be adjusted in your model, you can get that information and adjust it so everything's built correctly. So that's just a little something coming down the line. So if you have any questions about anything you saw today, I know this is a pretty long webinar today, almost an hour. Give support a call. If you have any concerns when you're messing around with the plugins or the custom members, go ahead and you can contact Bruce, or you can contact support, and we can help you get a hold of Bruce and let him know the concerns or issues that someone might have run into. So again, thanks for taking the time today and sitting through this longer webinar, and have a nice day.